heritage beam, and I think many other aspects which I'm not very familiar with. I'm sorry. And he has numerous publications on H-beam and beam LiDAR, and also led multiple digital documentation and preservation projects funded by the US government agencies. And today, he will share with us a lecture titled with Reality Capture for Built Environment and Heritage Beam. So, Professor Liu, the floor is yours.
Thank you very much, Dr. Ding. Thank you for your introduction. It's my great pleasure to talk to all the friends, all the world, and I heard it's a pretty large audience. I'm so happy to meet you guys. Hopefully down the road we can meet in person, but right now we're doing everything virtually. So my name is Junshan Liu. I'm a faculty member at the School of Building Science at Auburn University in the US. So let me share actually some of the slides of here's the kind of highlight of my research and teaching at Auburn University. As Dr. Ding mentioned, I've been working extensively with heritage structures, including buildings and bridges and even battleships. So my so-called expertise is on documenting and digitally recording those structures, and then present them to the public, and also digitally preserve those important heritage, we call it. All right, so I've been in BUCA, I call that probably my third home, right? I originally came from China. I got my hometown, and then I came to Auburn for 20 years. I've been here for 20 years. That's my second home, and BUCA is my third one. So I've been having so many visits with faculty and students at the BUCA. This one, the photos show, I think I had this one, the end of 2018. So we were visiting one of the college there. We took photos with the faculty and students. There's another one we had the summer of 2019. I was leading a group of students, Auburn students, to visit China. So we had really, really good meetings and collaborations with the BUCA. So we took a picture in front of the 3D printed Buddha. So that's on BUCA campus, which was really, really impressive. All right, so just continue on background. I received my civil engineering background or education back to China. That's before 2000. Then I started working as a construction engineer, later became a project manager in Shanghai before coming to the US. Then I studied in building science and then become a faculty member at Auburn since 2003. So you can tell how old I am, right? I've been teaching for over 19 years. This fall, I'm starting my 20 years of teaching academic career. And then also I do I call it construction consulting work. So I also work with some contractors and some companies in the US, providing technical support, especially in BIM, and also related capture the technology to those companies. All right, so my teaching and research at Auburn, I teach mainly, my main teaching area is construction infotech, and also called construction information technology. And since I got my civil engineering background, occasionally I teach some structure classes in our curriculum. And also I have OSHA, like a safety training certificate. So I do construction safety training management or management training as well. My research really focuses on BIM. So BIM is a broader topic, but my more specific area is using kind of work around heritage or historical buildings, then use some advanced technology to digitize the buildings, then convert the data into BIM. So it's called Heritage BIM. So I will have some slides to introduce the technology and the progress of HBIM. So that's pretty much a background of myself. At the end of my presentation, if we do have some time, I have a few slides to talk about Auburn University in general, and also my school, my college. If you haven't heard anything about Auburn, hopefully I have an opportunity to present some information to you guys. So here is outline of my presentation before this thing started. Dr. Dean, Mr. Huang, and I will discuss how much time we have, right? I told him I have over 200 slides. So I can definitely go over an hour, but it's going to be hard to make 2 hours. So basically, anyway, I want to keep everything in an hour, or otherwise it can be boring. So my outline, I will cover the basic technological tools of documentation, digital documentation. So including LiDAR. I know for many folks here, that's a new word. And the photogrammetry is another new word. It's even harder to pronounce for me. And then we talk about the drone, UAS or UAVs. They're going to discuss the 360 photography. At the end, I introduce Heritage BIM or HBIM. So for questions, if you do have questions, I recommend to keep them at the end. We have time to address any questions or comments. So the first thing I want to show you guys is called the LiDAR scanning. I have a few slides. So the first one is the introduction, the concept. Actually, LiDAR has been there for like a decade. It started being used in the military. So it's basically, I have a picture here. It's not mine, but it's kind of based on the research from a research paper I quoted. So if you have a laser device, right? You should have laser beams. The laser travels the air or vacuum. It has a really specific speed. For the laser, the laser travels at 300,000 kilometers per second, very, very precise. So the device should have a laser, right? The laser, meet or hit some object, right? It's going to bounce back or reflected or deflected. It come back to the same device. Based on the time the laser travels in the air, right? The device can calculate or figure out the distance between the device and that object. Just because the speed of light travels in the air is that process. So based on that distance, it's like a little digital, that's called a US, like a laser measurement. So if you have a device that can send out a lot of laser beams at the same moment, so it can get a lot of points matched at the same time, right? At the end, instead of getting one distance, like one linear distance, you can get a thing called a point cloud. All right, so like if you picture here, I have a picture, two pictures of a point cloud, the one on the left. If you only have a few points, like a few hundred of them, you can read out the frame, the shape, right? But if you have a lot of points, like the one on the right-hand side, you have like 500,000 points. All the points clustered together, they look almost like a surface, which is called a mesh, or somebody even called a model. So that's what you got from the scanning, a 3-dimensional point cloud. So here I have a YouTube video showing or explaining the scanning or how that works. Let's see if yeah, it works now. So right here, I don't know if you can hear the audio of this, but explain how
We cannot hear the audio.
Okay, so basically, let me repeat that. Explaining the laser scanning, what the Leica, the brand scanning works. You show the laser, the green. It allows the beam the same moment to reach the object and bounce it back to the scanner. So it detects the distance from the objects to the scanner. So all the measurements are recorded at 3D point cloud. Just to show that's kind of the angles, the distance, XY coordinates of each point. So here's the result in the scan, the 3D point cloud, just a lot of points. So here, just like a point cloud, also has a technology called colorizing. It assign some colors to the points, and at the end you have this colorized three-dimensional point cloud. All right, I'm sorry you couldn't hear the audio, but I can share this YouTube video with you guys after the presentation if you're interested. All right, here the 3D point cloud. Now I'm going to show you the point cloud I captured next a few slides. And the device we used for LiDAR is called a laser scanners or LiDAR scanners. There's quite a few manufacturers making this and also like selling them. And I've been using two different brands. I start with a Leica called a ScanStation C10. That's about 80 years ago. I started. You see on the left is a really big scanner. It's about 50 pounds or 23 kilos, just the device. And also is really expensive. I'll show you kind of how much that cost you. The second one or the third one is they both manufactured by Faro. So they're much smaller. And for us to use them in construction management, we would like to have something smaller, right? Mobile, so we can put that under the foundation, like under the structure, like this one called a crawl space. And also we can have them in the really tight space, like in Battleship. So those scanners become more popular and also a lot, I mean, much more affordable or less expensive. So I want to show the specification for each scanner here. As mentioned, the Leica scanner is really big, right, heavy, but the technological feature is quite impressive. It can capture 50,000 points per second. So that device shoot out laser, a lot of laser beams per second. Now 50 can get like 50,000 points. That's a lot of points per second. This thing can spin 360 degrees horizontally and 270 degrees vertically. So the kind of space the scanner will not be able to capture the right end of the tripod. As you can see the picture, it won't. That's kind of that spot or that angle for the scanner. It can reach really far, go as far as 300 meters or a little less than 1,000 feet. That's long distance in terms for laser scanning. It also has a built-in high-resolution cameras. Take some take some pictures, and it's big, right? 50 pounds, and it costs a lot of money. It's $150,000. Time we bought it, that's 80 years ago. That's a really expensive device. That's only for the hardware. It costs more to purchase the software, and also costs a lot more to have the people to operate and maintain the device. So the next one, I started using the Faro. I called X130 about 4 years ago. It's a smaller scanner. It can actually capture more points. It's always almost like 1 million points per second. All right, 20 times the one you saw on the Leica. So the same like a field of view, right? 360 degrees horizontal and 300 degrees vertical. And the range actually longer, shorter, I mean, 130 meters compared to the Leica, or 400 feet. And has built-in HDR camera. It's much, much smaller, the 1/4 of the Leica. So that's one I can carry really easily, right, in a building or like a really tight space. It costs more, I mean, less than 1/2 of that of a Leica. It's $60,000. Then about 2 years ago, I started using the newest model called S series by Faro. It's the points captured about the same number of points per second, right? The longer range, 350 meters, and only 10 pounds, and the less expensive, even means smaller cost, like $50,000 for the hardware. That's a lot more affordable now. Technology has gone a long way. All right, what I scan, I mean, talking about all the LiDAR, the scanners, right? I mean, things started getting boring, but I want to make it more attractive, more interesting. All right, what I scan, as I mentioned in the beginning of my presentation, I work with a lot of heritage structures, right? The buildings, bridges, and the roads and the ships. All right, so for us at Auburn School of Building Science, so we teach construction management. So we work with the new buildings on the project size. So I have been scanning a lot of ongoing construction projects. So this is one of the structure labs I scanned March of 2021 on Auburn campus. So that's right after the steel was erected, steel structure was erected for the building. So I scanned the structure, the steel structure, right? The purpose is that to document the steel, like the columns, the beams, the girders, and also the connections, because those steel structures will be covered or enclosed later on in the construction process by the walls, right? Or the glass, the curtain walls, we call the roofs. So the people won't be able to see the majority of the steel members. But down the road in the future, if the building to go through renovation or maintenance, people need to identify the exact locations and condition of the structure steel, and they will have a problem, right? But if we have a digital record, digital scan, the latest scan of this, we can open up the point cloud and computer to show them exactly where those structures still are. I mean, what the condition they were when they were erected. So here I'm going to show the close-up or details view of the scanned point cloud of the structure steel. As you can tell, it's really, really detailed and also comprehensive coverage of the building, just a steel part. And also the accuracy, you will hear me saying the same word, accuracy, so many times in the presentation. So the accuracy is very, very good for the laser scanning. It can be, I mean, as accurate as 2 millimeter. So that gives you the capability to go into the point cloud on your computer and take a measurement, right, of the structure. So that's something wasn't available before LiDAR technology. So this is another construction site that scanned in last May. So it's another building on Auburn campus. I have a few slides talking about that later, but you can see this kind of documentation or record of ongoing construction project. You can see the slab, right? The concrete slab or the board. There's a lot of construction materials. In the background, there's a structure called a metal stud. So this metal stud is kind of framing member for the walls, for the partition walls, which will be covered by the walls. So we have a record of that. It can be easily accessed. All right, so here is a renovation. I scan a lot of buildings, like a heritage building or existing buildings for renovation purpose. You know, when you need to design like a retrofit or renovate a building, reuse a building, you need to have an accurate measurement of the existing condition of the building, right? And then the designer can use the measurements, come up with a new design. So this building is a 3D point cloud of building scanned, and that's interior of that. I just removed the roof on the point cloud. You can see the inside. It's kind of it's a water pump for a pump house. So there's a lot of heavy machinery in the building. So I scanned that before the demolition, the heavy machinery, and also I had another scan right after. You can see the space opens up. So this, again, is a really accurate digital record of the building. So people use that for design. It's another project in scan in Birmingham. That's like older scans, also for a renovation purpose. All right, so here, I mean, people may ask, how would you do the scan, right? Do you just take one scan to cover the entire building? Or you have to do multiple scans. So normally, LiDAR is not accurate. It doesn't go through any object. So to cover a building, like especially inside and outside combined, you have to set up the scanners multiple locations, like around the building and then inside the building, in all the rooms you want to scan. So here the picture is actually one of the older projects I did years ago. It took me 5 hours. I would use the LiDAR, the Leica scanner, the older one. It took me 5 hours, and the scan Leica C10. I set up 7 different targets. The targets were used as like reference points to connect the multiple scans together. And set up 10 different places. You see the red dots, right? It's a small museum building in Alabama, so you can see the red dots. It covers like 7 of them outside and 3 inside for the entire coverage. Then at the end, I have 780 million points captured for this point cloud. So here are the pictures of the point cloud we recorded using the scanner, so you can see the overall image on the top right. Then there's 2 smaller ones showing highlight the front entrance and also the interior. Because there's so many points, it almost like looks like a photo, right? And also I scanned the stadiums. It's Auburn University American Football Stadium. So it's a really large venue. Stadium. It can host like almost 90,000 people. So I scanned that. And also I scanned some older forts, like this American Civil War fort in Mobile, Alabama. That's another research project I did years ago. And more recently, I got involved with local heritage documentation or preservation. That's a smaller historical building I scanned in Lanett, Alabama. And then I also do a project with the colleagues outside the US internationally. So this project I did in Valencia, Spain, early this year in March. I have more slides to kind of like showcase how I did it and what this building is about. Just right now, I want to show you the kind of result. For this one, I had over 300 scans. At the end, we captured 5.6 billion points. Let's start with a B, so that's a lot of points. So here's another like a cut, another view of point cloud of the same building, just so many points. All right, and also I work with U.S. Army Corps engineers, like the military construction. This one, the Army barracks I scanned in Georgia. So this is also a large project. It took more than 130 scans for renovation purpose, and they got a 1.8 billion points. All right, and also work with the battleships, right? The World War II naval ships. So this one is called USS Alabama battleship in Mobile, Alabama. I had a project with them. So here I want to show you guys a small walkthrough, like animated video of the captured point cloud. This point cloud is just a small fraction of the entire battleship. So I spin this again. It's not a model or a picture. This is just a point cloud. It has, I think, like 1.8 or 1.7 billion points. It covers the front, which is called a bow of a ship, right? The front, you can see the main guns, the superstructures, and also I had some scans taken inside of the battleship. As you can see, the end of the deck, the middle, it's like looks like purple. So now we're getting into the close to the deck, and then we'll go inside. So showing this, I want to give you like understanding of how detailed the point cloud can be, right? And what it can capture. So those are like a black box hanging in the air. That's where the scanner was set up. So now we get inside, we're gonna turn left. We actually will go down a little bit, a couple levels. So you can see the scanners, there's a lot of scanner setups. So another level. Again, this is not a video, it's animated, I call it fly through of the point cloud. All right, so here another, just a still image of the point cloud captured of one of the main guns of the battleship. Just want to show you guys the details, right? It's a lot of points, so dense, they almost look like a model. So here, talk about the measurements accuracy. You can go in this point cloud, then measure, like pick up 2 points, and then find out distance between these 2 points. This is very, very useful feature for construction or for record, digital record of a building. So I don't know if you may have heard called a digital twin, right? This point cloud is one of the important or the good technology, very useful technology for digital twin. So here, the same for battleship. I'm going to show you a set of picture to show the comprehensiveness, right? The coverage. You can see it's really, really complicated structure for inside the battleship. All right, this is like small section of one of the rooms and how complicated of that battleship, right? You can see there's a walls, floors, ceiling, and the pipes for the air conditioning system. We call it mechanical system. There's a pipes running the water, right? Or like supply water, hot and cold, and also returning like a sanitary water. And you can see like also the electrical, like we call it conduits, right? The wires, cables. It's just like a mess, a big mess. So here you can see the point cloud that can capture almost everything you can see with human eyes. And also you can cut a smaller section to show the 3 different levels of the battleship inside. If you want to check more details, you can zoom into one of that, right? They all can be done on computer using the point cloud. So here, this room called a damage control room. If you want to see what happened to the wall there, this box is for, right? The switch panel for damage control. You can zoom in to look at it again. You can also, if you cut a small slice of one of the rooms in the point cloud, then make like a plan view. This one can be converted or can be used to make CAD drawing, right? Computer aided drawing, so like a 2D plan, and then you can use that to design. Because there's a museum now, right? The curator of the museum, they want to know how much space this room they have. They can set up an exhibit. This is very useful tool for them. All right, what else? So other things I scan, I also scanned the submarine. That's another project I've been working on since last year. It's a World War II submarine. So we scanned this, had digital record of that. And that's kind of the guns on the deck. And also the aircraft is another World War II aircraft, the B-25. We scanned that as well. We also scanned trees, right? This is one of the symbolic trees on Auburn campus. But unfortunately, both the trees died a few years ago, and then they were removed and replaced. So we scanned the trees before they were removed. There's a long story behind that. So I also went to the desert to scan some rocks in the desert in Wyoming. So I was working with archaeologists to use the technology to try to figure out if the later scans can help people identify some dinosaurs fossils in the rocks. That's quite a big rock I scanned. So since I do so many scans, sometimes I got some byproducts like human, right? Just 2 other colleagues of myself scanning the job site, so we got ourselves captured. And the one on the right, that's myself. I actually took this one in Central America, in Ecuador. So I was doing a project, just sitting next to my scanner. I got myself. I like this one. And also sometimes we get a ghost. You know, the later scanner can scan something invisible, right? You can see it kind of zoom up, like close up. You can see those like little kind of shadow that's the ghost lived in the building. All right. So why we scans, right? What do we do? How we what the point cloud can help us here? I make a list of, especially for design construction professionals. Using LaserScan can give you really good kind of as a build documentation. So as a build, that's kind of is a record of existing or completed buildings. And also, if you have an existing building, right, old building, you want to convert it to a new building, you want to just kind of restore it or renovate that, you can take a scans, you can have the really accurate measurements. That measurements can be used for design of the renovation. If you get a good point cloud accurate, you can use the point cloud to develop BIM models, building information modeling. And you can conduct land survey for like a field using LiDAR scans. And if you scan the structure periodically, right, you can monitor the structure deflection, structure settlement, or damage of that. All right, the pros and cons or advantage and disadvantage of LiDAR technology. First one, I keep mentioning that accuracy of the scanning is really high. So you can have a really true as build, and you can check the progress if you scan the structure periodically. But it's also very expensive. Like the 3 scanner show you, at least it costs $50,000 a piece, plus software and plus the people running that. It can be really costly, right? Only large contractors, a large design firm can afford that. The next one to introduce another technology called 3D photogrammetry. I probably need to kind of speed up a little bit more. So photogrammetry is a technology that uses photos only. So you don't need to have those expensive scanners. But if you have a really decent camera, even a cell phone, right, you can take a good pictures. If you follow certain rules, taking pictures, they overlap like each other, and then you import the picture to a particular software or photogrammetry software. The picture will be processed, then make a point cloud using like a triangulation. Like this one, right, we have pictures of a small fort. Then the software, will process the pictures, generate a 3D point cloud. Yet, end product is also a 3D point cloud, like the scanners, the LiDAR scanners, like this one. So we have a lot of photos of a person's face. We process them, make a point cloud. So as you can tell, the quality of the point clouds are also very good. The accuracy may not be the best, but the coverage, the visual result is also impressive, quite impressive. So by doing this, you will have a point cloud of a building. Like this one, I have used 110 pictures to cover a basketball arena or venue on Auburn campus. So we have the point cloud created right here. This cloud has more than 14 million points. So you can see the roof are really good, right? But the front facade is not much. See, it doesn't capture any glass walls in the building. Just the image are really limited. Also, the accuracy is not a match with the LiDAR scan point cloud. So this, like I call the raw point cloud generated from the photogrammetry using aerial photos. We had with the 560 photos. That's kind of the initial result. Then we refined, revised that to make higher quality. So we have 42 million points of this building, also on Auburn campus. The battleship All right, Battleship Park, we flew a drone, a UAV, to take a lot of pictures. This probably has more than 1,000 pictures. And then we made a photogrammetry point cloud. You see the battleship and also the submarine at the lower right corner. So here, and also you can create specialty pictures called a photo mosaic. This can actually, this view is not single photo, it's a stitch, it's kind of hundreds of pictures stitched together and projected and to make a one photo mosaic. You can see the document of the decking of the battleship. So the technology is for photogrammetry, like basically you fly a drone, you take pictures of structure, right? Then use the program to process them to make a point cloud. So the point cloud can be used for documentation, even if it's not accurate, but still good coverage, right? For renovation and land survey and making a BIM model. The pros for photogrammetry is number one is very, very cheap. As long as you have a good camera, right? You follow this particular route to take photos using the camera. You may put a camera on a drone or on a UAV, fly them. So that is very cheap. Most likely it costs you probably just a few $1,000 compared to $50,000 or $100,000 of LiDAR, right? And also because it's cheaper and it's more mobile with the camera, so you have more flexibility to capture the data using photogrammetry. You can also capture a larger site if you fly a drone for that, and less training required. But disadvantage is number one, the low accuracy. And also you can take a picture in the dark, right? You cannot fly a drone if it's a high wind or rain, the bad weather condition. All right, so the trend, the future for LiDAR technology actually is to go airborne. So like, I know there's a manufacturer start making a drone-based scanners. One company is US-based. It's called Micro Drones. I've been talking to them for demonstration. Another one, the Chinese company, got DJI. They had their first generation LiDAR scanners on drone, it's called L1. So it's one of the best available in the market now. And the most recent, I had this one, Leica just released early this year. It's also a fully autonomous drone-based LiDAR. It's called a BLK2FLY. I was able to participate or attend a demonstration in Las Vegas last month. I'll show the small video. So the drone was flying and captured one of the big hotels in Las Vegas. And you can see the scan the particular pattern to capture the walls of that. Then the turnaround, there's ongoing construction site also capture that. So fully autonomous, that means it will fly in and out to identify the structure. It will avoid the clash. It got a really, really good coverage. And the next technology is called a 360 photography. This one, the end product is the virtual tour. I've been using this like for a couple of years. This is newer technology. So this one can create, let me show you a link to this. It creates a thing called a virtual tour. I know you guys have seen this before, like a virtual walkthrough. So basically this kind of interactive 3D or 360 imagery. So you can go in, like you can click on the white circles on the ground to move around, right? You can look around. This one, the historical church in Selma, Alabama. It's tied to the civil rights movement in the US. So you can move around, right? Just like pretending you're walking inside the building. Then you can, spinning or turn around and zoom in, zoom out, look at the details of that. So this one, very, very user-friendly. It gives the visitors ability to access the structure or the place virtually. It worked really well during the pandemic, the COVID-19 pandemic. So a lot of museums using this to allow people to see, right, to have a visit virtually. So here you can see we got a balcony. You can look, all right. You can even open up some floor plan views like this one, second floor plan, or I can switch to the first floor plan. So you can see that. You can even take a measurements of the building. And for construction, you can use the same technology to scan a new construction, a new building right here. Okay, it's an example. Then you can attach additional information in this virtual tour like this one. This one tied to a specification or manual of a particular equipment. It's a PDF document. People want to learn more about this equipment, or the operator, right? The user of this room want to see what this equipment about, right? They can have access, open this one up. That's another piece of document. You can tie it to a video, right? Video tutorial showing how to operate, how this equipment works. And you can tie it to hyperlink or to photos. So a lot of stuff or comments. This one is really useful for new buildings as well, because this feature of linking other information or documents to this tour. So this one I captured a submarine for the Battleship Museum. So it's still ongoing projects. It's the battleship as well. This is another tour I captured in Valencia. So it's a large project. Again, the end, the 360 photography just gives you a virtual or image that allows people to visit that virtually. So think about a museum, right? Or education can use that. All right, so here I have a couple case study. I want to kind of combine the technology and the three pieces of technology, right? I want to put them together to make whole story to show you guys how they work, incorporated and coordinating together to document historical building. So here, this old courthouse in Florida, Central Florida. The building was built in 1908. It's a little over 100 years old. It's a courthouse, but now become the museum for the county. It's like about 5,000 square meters or 50,000 square feet, has 3 levels. So the purpose of the project is documenting the project, has a digital record of that, and also making a BIM model out of the record. So here, just like the timeline, the structure, the building built in 1908 had 2 major renovations, addition, and now became a local museum. So historical photo on the left, the original, right, and the current project, current view on the right. So just like some field photo of that, we captured this one in October 2021. So we use a different technology, including LiDAR and drone, all right, the like 360 photography, and also we use the old school, the conventional way, like tape measures and taking pictures. So we also did the research to find the historical records, including drawings and the newspaper articles about this building and also its renovations. So here, this original floor plans showing the basement. And the equipment, so here before we started, just let me have a picture of all the equipment that we brought to site. And also we did a pretty intense, like a planning. We check the weather, right? We kind of estimate how much time we have, how much time we're going to use to capture that, and also accessibility, and also the scanning, like the plan where we start, right? This is the floor plan we use. We mainly captured the area inside the red lines. So here the equipment that we used. So start with the scannings. We did 2 scanners at the same time. 13 hours total spent on scanning. we took 241 scans, and at the end we had about 2 million points. So it's estimated we're going to have 2 million points, 2 billion points. So here the picture showing where the scanner was set up inside, outside, and also the up in the dome. So a little bit set up the scanner, the interface. So we took a few of the nodes to show where the scanner where we had the scanners set up. So the 360 photography is the Matterport Pro 2 3D camera. We spent 6 hours. We had 470 setups. And that's kind of the result of the scans. You can see those blue circles. That's where the 3D camera was set up on 3 different levels. I also flew a drone to capture that building in the right circle, right? And just for the roof structure, because when you later scan, you do the 360 camera, you cannot reach the roof just so high up. And then I flew a drone to take a lot of photos. Like I had a 950 photos just for the roof structure. So 200 of them just looking down, kind of bird eye view. And then 750 of them like oblique angle, 60 degrees. I flew 150 feet. That's about 45 meters above ground. And each picture has pretty good resolution. So here with the DJI drone, you can see the flight patterns. We fly 5 different routes for the above the building. You can see the background, that's the courthouse. And that's like I was trying to launch the drone, it's DJI drone with my cell phone as on the remote control. Some picture captured during the flight. So also we took measurements to check, verify some of the detail of the building, also the structure steel over there. Start processing data at the night. So we had a field capture in the daytime. We work on the result, the information at the night, running 2 computers side by side. Then we had initial data. You can see the point cloud. And also because the scanner can reach so far, you can see adjacent buildings and the conditions also were captured. So the courthouse building, it doesn't look really nice. That's the kind of initial stage. But at the end, we have 1.8 billion points from all these 241 scans. You can still see there's a lot of information missed, like the roof, right? This later scan, it doesn't have the drone pictures. And the dome, and also you can see we miss the top part. It's a section cut, you can see the inside, actually the inside capture was very good. This is the virtual tour 360 photography of the museum. So like 3 different levels of floor plans. And this is a little animation of the virtual tour. Okay, so here I want to show the actual tour. So here the drone image, you can see all 950 pictures. They all align in the air. And the process in this photogrammetry point cloud, mainly for the roof of the building. So here there's also a mosaic view of the roof. So like a summary of that, we spent a total of 30 hours on the field. We have a group of 3 people. And the post-processing in the office about 12 hours to get the point clouds. And I would see we covered about 70% of the surfaces of the building. But there's still quite a few sections of the building were not captured, like because of the accessibility of the spaces, and also like the roof part. Cost estimate, I know there's the professionals company that's doing this kind of thing. They're quite expensive in the US. All right, the second case, that's what I did in March in Valencia, Spain, so in Europe. So this one, the historical churches, It was built in 1583, really, really old, like almost 500 years old. It's a symbolic building in the city. So we were able to capture that to show the map. This is Spain, Valencia, this where the building located at. So we had 2 scanners, we like 42 man-hours. We captured a 341 scan. That's the largest scans ever captured. Then we got like just look at those numbers, 5.6 billion points. Just you need to large space, have large space just to store the data, 210 gigabytes of the project data. And also we convert the data into different formats. Each file format is really, really large. So the picture shown here is a map where the scans happened. So set up, so here pictures inside the church, right, the scans. And we also went to the attic, went to the library, and this came to the main church. On the library, we have double scanners side by side. And the exterior as well. And my colleagues in Spain as well. So it's the roof and the field nodes for the scans. So here the overall kind of raw data of all the 5.6 billion points you can see got not only the church, also the buildings around it, the roofs, quite crowded. So the kind of close up view to the church, not isolate to the church only. Just cut a clean cut of that. Really, really good coverage. That's kind of section cut. You can see the inside. There's a museum. There's like a dorm room, the conference room. You can see it through. And at the side, the courtyard in the middle. Okay, the church, different section. Just to see how much detail, right, it can capture, how it can dense the points. It's a floor plans, 3 different levels in the roof. And also the artifacts, that's one, the sculpture in the courtyard. And we use the 3D cameras to capture the imagery to make a virtual tour as well. Just kind of showcase the quality of the technology, just the visual quality. All right, so here that's kind of the last part of my talk is about another technology that's actually kind of extend, right? Once you have this digital record of 3D imagery, you have the zoom photos, you have the later point cloud, you actually can process the data and move them to another level, just make a model, build a model, and then the model can be a digital tool, and the model actually can capture more information if you attach the historical records, the videos, right, artifacts to it. The model become a building information models called a BIM. If the model is for heritage or historical building, it's called a heritage BIM, HBIM. So here it's kind of the HBIM is just heritage historical building information models. And our process that's kind of produce intelligent BIM models to contain or to host the information, including the historical record of that building. So here, there's a real photo of the bridge, and then the HBIM model to develop for that bridge. So how it works, I mean, it's quite a simple 3-step. First one is to collect data for the structure you work with. Using scanning, right, the photos and 3D imagery. Then you develop models, right, using the data capture, the model to be really accurate. And then you attach information to the model to make it a true heritage BIM. So here, there's a different technology to use to capture the data. I want to show you like a case study later, but here there's all the software involved. There's modeling software and also the data capture, data processing software available. It's kind of A lot of pieces you got to put together to make it work. All right, so from the developing process, like basically you have the point cloud, right? You have the imagery, you import information to a modeling program like this one. You can see point cloud in the background. Then you make a model and then hide or remove the point cloud from the background. Just leave the true model there. Another picture, the old Depot Museum at developed in Selma, Alabama. The picture model development, you can see this actually was in Revit, Autodesk Revit. Then you have the model rendering, information attached to it, just some pictures, historical photos of the windows and doors. So a little case study for that project. So one of the old train stations now become a museum in Selma, Alabama. So it got like a lot of artifacts for prehistory American Native Indians, and also for the Civil Wars and World War II and the Civil Rights Movement as well. So we were able to find one historical record. This is a sketch of the building floor plan. That's it. That's all the drawings we were able to find for that building. But we took a lot of scans, like the LiDAR scans. We got a really good coverage or measurements of the building. Then we were using the scans to make a BIM model, just like point cloud. The scans, you see the little basement inside one of the civil rights rooms. And also we flew drone to capture the roof structure. Just aerial photos. Okay, so here the modeling process. We start with the point cloud into Revit, just import information to it. Then build up, like set up the main levels, elevations to it. And then we model the walls and the floors at the roof, ceilings and the brackets, and the doors and the windows, right? And at the end, we have the decorative elements like trims, moldings to make a model. So here is the renderings of the model. And like section cut. And even we try to 3D print to create a physical model using the BIM model. So another project I did also in the Selma, that's the bridge. One of the ones important civil rights structures. Actually, if you guys heard about a Bloody Sunday, or if you watched the movie called Selma, so that's like where it happened on this bridge. The Bloody Sunday March actually started on the bridge. So I got a grant to work on this. I was making a record and also the HBIM model for the bridge. So we're able to find the original drawings. The bridge was built in 1940s. So found the drawings, historical drawings, and this point cloud. It took a lot of time for us to scan the entire bridge. This entire point cloud you can see on and under, but still we left a lot of voids. Some of the places were just unable to capture, just so far and too high. So just a bridge, the point cloud, the ratings, and also flew drone to take some pictures. And here the point cloud, all right, it's a model, it's kind of structure steel model. The photo. So here I'm going to show you guys a set of three pictures. So this picture of the bridge, this is a point cloud of the same part of the bridge, and here the HBIM model of that section. Another view, bridge, the picture, point cloud view, and the actual BIM model. So the readings, as you can see, kind of combined with the point cloud. So I call it the most accurate HBIM model for the Selma Bridge in the world now. It's only one. So more pictures of the project. So I know I keep saying this like HB model, point cloud, right? So the purpose of the thing, the process, or the technology is to have accurate, comprehensive, and a detailed record, digital record of the structure. So if the structure got lost, something happened to that, right? It got lost, you still have the record that can be used to restore, to rebuild it. Or another way to look at it is digital record can also be used to make a presentation or can be accessed to the general public if the citizens they cannot visit the place in person, but they can try to see it, to visit that virtually online. So here, we're the future of the documentation. The technology is going. One thing, the robot, right? So here I have the video. Actually, my school, my department owns this device. Okay, you may heard about the Boston Dynamics. It's a robotic dog. So we put a scanner on top of the dog, and we walk the dog on the job site to do the scanning instead of having human to like move the scanners around instead of a job, but the dog can do that. And also you can program the dog. Suppose the dog can walk on the job site at the night program, right? So that can save the human, the labor and the time to do it. So that's kind of, I did a little testing with the dog and the scanner on the ongoing job site with my colleagues. Also, you can see the construction workers. Every time the dog comes up to a job site, people like to take pictures with it. So here the video showed how the scanning is it's done with the dog. You can see the scanner, the ferrous scan on top, and here the quick video. So the other location to scan the programmed and assigned given to the dog. So going to go to the spot, find the location and pause there and start scanning. So everything was pre-programmed. We didn't hit a button to do it. So that you will see the scanner start to spin here. Yep. So the scanning started. The dog just paused there. Once it's done, the dog will start walking next to the next location, scanning again. So another thing one thing we found interesting, the dog actually has a really good self-balancing capability. You can see this is really rough. This is typical on the job site, especially in actual, right? So the dog were able to find a way to balance itself to make the scanner very level, right? Can start the scanning. So another interesting video I captured, I don't know if you guys want to see it, the dog's really, really intelligent. You can see walking some pipes, losing pipes. It still managed to balance itself. Okay. So as I mentioned, I got a few more minutes left on the cover and shows a little bit about my university and also my department. So Auburn University is one of the largest universities in the state of Alabama. So we have more than 25,000 undergraduate students, and combined with the graduate students, we are over 30,000 students with about 1,300 faculty members. So we started in 1856. So there are two state flagship, we call it public flagship university in the state of Alabama. Auburn University is one of them. So we're ranked one of the best universities in the US, and also we are R1 at the research universities. So the location of the state of Alabama is in the southeast of the US, and we are like the east, central east part of the state. Right here, you can see that the biggest city close to Auburn is Atlanta in Georgia. So it's about 2 hours of drive from Atlanta to Auburn. So for my school, it's called Mike Water School of Building Science. We started in 1945. So we're in the College of Architecture, Design, and Construction. So we graduate like about now it's actually more like about 180 students each year. And we have undergraduate degree in construction management. We also have master degree in building construction and even doctoral degree, which is started about 3 years ago. We also have online programs for professionals who still work like a full time, but we have online programs available. So that's a little more about it. So we have a LEED Gold building. It's the first LEED Gold building, public building in the state of Alabama. We also have a field lab of our building. So another part of the campus, similar construction site. And we encourage the students to participate in all the activities like study abroad, competitions, students organizations, and internships. So we're really proud of that. I think that's the conclusion. My presentation, we managed to complete 215 or 14 slides in 1 hour over 8 minutes. All right, now I can take questions. Or if you
Okay.
guys have any questions.
Thank you very much, Professor Liu. Yeah, I think if I remember correctly, Auburn University is also have a very famous alumni, NBA Hall of Famer Charles Barkley.
Yeah, that's NBA. That's one of the sports figures, Charles Barkley. Yeah, he is, and also Tim Cook, the CEO for Apple
Really?
Corporation. Tim Cook is also graduate from Auburn. He got his undergraduate degree from Auburn. That's another famous alumni.
Okay, I see there are questions in the Q&A part. If you can click the Q&A tab, and you will see there's a student ask some really technical questions.
Yeah, I see the first one. Yeah, mannequin then, right? Yeah, he's asking if we can prepare 3D point cloud for entire building by only images. I mean, convert a video to image, then process 3D point cloud. Yes, you can do it if you have enough pictures and cover the surface of the building. The pictures, I mean, normally the requirements, the picture they need to have a 60% overlap. You can't take a picture at one wall and take another picture at a different wall and thinking to connect them together. No, it doesn't work. So you have to have a lot of pictures. They all like overlap together. So the picture can be connected together and being processed using photogrammetry. If you have enough pictures, good coverage, and good software to process them, yes, you can have one single point cloud from them. But that it's just you cannot expect the point cloud to be really accurate. It just the limitation technology is not there. That's kind of the accuracy is not there yet. So the best tool if you need a higher accuracy, the best technology is still LiDAR scanning. All right. So yeah, he has another question. What's the criteria to set up a camera, Professor? Is there any special calculation required? Assume just make sure to cover entire area. So the overlapping, the number one, also the lighting conditions is another one. So I mean, don't expect to get a good result if you take pictures in the dark or there's a lot of dust. And also the distance from the camera to the wall, to the object, I would keep those distance consistent. Camera position, yeah, that's gonna address that. Yeah, so I think like Daniel, right? He asked if one or she asked if one the disadvantage scanning the slow. The slow, I mean, if you do the LiDAR scanning, you have to take a lot of scans around the building for the exterior, and also scans for each room, or maybe multiple scans in each room. It's large. So that takes time. Basically, based on the setup, the scanning, the resolution I call it, each scan can take from 2 minutes to like a 20 minutes, depending on the number, the accuracy, or not accuracy, the number of points, the resolution you want to capture. That will slow down the scanning process. Like the project did in Valencia, it took 341 scans. Either resolution, so each scan is about 6 minutes. Just think about 6 minutes multiplied by 341. That's like 2,000 minutes already. That's a 30 hours straight for one single scanner, right? Plus you have to have time to move the scanner around, set it up. I mean, sometimes the battery is out, you got to swap the battery, take a break. And that's kind of why the slowdown. I mean, that's why the slow process.
Yeah, it's a trade-off. If you want accuracy, yeah, you
Yeah,
must spend the time.
That's exactly accuracy, and also the higher density, higher resolutions, you're going to like take more time to do it. But if you want to kind of speed up, especially for open field, like on the land survey, the accuracy is manageable. It's not as tight as the interior building. You can fly a drone, take aerial photos. That will be much faster to cover the big area.
Mm-hmm. Actually, I have a question. As you mentioned, if you're using LiDAR sensor, sometimes you cannot capture some part of the structure and or a building. But you have already introduced the 3 types, mainly 3 types. But can you integrate all these different sources of data to make it more holistic, to make a whole model? But is it difficult technologically, or even for the processing hours? Is that feasible, or it's just too time consuming, or energy, or the computational power it's required ridiculous?
Yeah, it's a great question. That's actually a multiple question. One, yeah, all this technology required a pretty good like hardware computer. You have to have quite a good computing power to process the point cloud, right? The LiDAR scans, the photogrammetry, the drone point cloud. Like the computer I use, it has like really the top notch, the CPU, and also 128 gigabytes of RAM. It's really kind of quite expensive equipment. You have to have that. And also, yes, you can incorporate the data captured using different technology. Like I can combine, since the LiDAR point cloud, I got from LiDAR, I got a point cloud. Then from the photogrammetry, I also get a point cloud. I can merge these 2 set of point cloud together. The drone give me the roof, right? The LiDAR give me the facade and the interior. I can combine them together to make one single point cloud. Yes, it is doable. And then also I use the 3D virtual tour, because the point cloud, if you look at the point cloud, they look nice and detailed, but they're still cloud that you can see through. Now the 360 virtual tour gives you the real imagery. You can zoom in. Also the visual effects are very, very good. So when you make a BIM model, the point cloud gives you the accuracy of the measurements. The 3D virtual tour gives you the good visual effect. If you want to figure out like the trim or molding, you can look at the image, then you can use the measurement to model that.
Okay. Okay, let's see if we have, yeah, there's another one.
Another one, yeah. How to deal with voice. Yeah, that's a good question. Like one the case study, like the courthouse mentioned, and then we spend that much time and the resources only get a 70% of coverage. Yeah, there's a lot of voice. You just cannot capture like really small space. I mean, just like a corner, steel structure, you cannot see. You can hard to reach. You just kind of sometimes you have to make assumptions. Other time, if you have like existing drawings or records, you can use that to compensate. So one the void I had with a bridge, as you can see the background. So the Selma Bridge is loading. So like the footings, the foundation of the bridge, right? There's no way you can dig, like have excavation to dig up the footing to scan it. No, you cannot do it. And you cannot take picture. The only record we had was the historical drawing. We just make assumption, right? The people built the bridge based on the drawings, really accurate. So I was using the drawings to make the foundation, the footing part of the bridge. So like here. So yeah, what would happen is expected. You just use your best knowledge, all the information available to, just to model or to replicate that. That's a great question you guys have.
Yeah, let's see. Okay, any other questions? No. Actually, you manage your time very well.
I don't know about that, but here again, if you guys want to reach out to me, I'll be happy to answer any questions or talk about if you guys are interested to apply for Auburn for your master's study or PhD, you can write to me. I'm pretty easy email, like prof.liu@auburn.edu. So write to me, please, and also again, it's my great pleasure to meet you guys online and speak to you. Hopefully, we can be in touch in the road down the future.
Yeah, we hope. We can only hope. Thank you very much.
Thank you, Professor Liu. Thank you.
Thank you. Yeah. So
Okay.
do we stay here or?
No, it's okay. I think
Good.
we can end our session over here.
Yeah. We have to end.
Okay.
Yeah.
Thank you again. Pleasure.
Yeah. See you, Professor Liu. Thank you.
Yeah. Bye-bye.
Yeah.
Bye-bye.
Have a nice day.
You too. All right. See ya.
Okay.
Okay.
See ya.
Okay. Every student, thank you for all your attention about our 14 lectures. Yes, but tomorrow there will be a very important ending, the closing ceremony at 3 o'clock p.m. Beijing time. I invite all of you Chinese students and international students can engage in our closing ceremony. And I will also tell you some details about the certificate, and let's have a happy ending. See you tomorrow afternoon at 3 o'clock. See you tomorrow. Bye-bye. See you tomorrow. My colleague from ISPRS Students Consortium. See you tomorrow, like me.